Hello, everyone. Good morning, good afternoon, or good evening, wherever you are, and welcome to the second joint IEEE ComSoc Santa Clara University School of Engineering virtual panel session. Today's topic are the critical cybersecurity issues for IT, which includes cellular networks, the Internet of Things, the Internet itself, and cloud resident data centers. We are privileged to have three distinguished speaker panelists. We have Jimmy Jones of Zariat, Colin Constable of the At Company, Thomas Forrester of Nokia. At this point in time, I'm going to ask each of the speaker panelists to introduce themselves, tell a little bit about their job function right now, and a little bit about their company involvement in these various cybersecurity issues. Our first speaker panelist is Jimmy Jones of Zariat, and I'd like to thank him for his patience. This event has been over 2 years in the works. I first spoke to Jimmy, when was it, February or March of 2020, and he agreed, but because of the COVID pandemic restrictions and lockdowns, we couldn't have the event until now. So Jimmy, the floor is yours. Tell us a little bit about yourself and your company's involvement in cybersecurity.
Well, thanks, Alan. So at the moment, I work for a company called Zariat. We're a cellular IoT connectivity provider, but with a particular focus on security. I've joined as the head of security to build out how we move telecoms forward to build a solution that actually works for IoT. There's a sea change happening at the moment between telecoms of where we were previously and where we're going, and we're looking to address that. Previously, I worked, I think when we were speaking actually, I worked for a mobile security penetration testing company, who also built signaling firewalls and IDS platforms as well. But overall, I've probably done 25, if not a few more years in telecoms, and a lot of it has been around telecom security, either in SIP in the early days or with mobile and the threats there more recently. And now I've moved into a very interesting area with IoT.
Thank you very much. Next is Colin from the At Company. I invited Colin to speak on in a cloud computing networking seminar way back in July 2010, and he did an excellent job. And I'm so pleased that he's here with us today at his startup, the At Company. Tell us about yourself, Colin, at the At Company, and its involvement in cybersecurity.
Sure, Alan. It's so great to be back with you and the rest of the team. So the At Company's mission is to flip control of the internet back to people. And we're doing that through a brand new network protocol, which I'll talk a little bit about later. At the moment, everything is very much centralized and you have not got any control over your data. We're trying to flip that. So you do have control of the data, and that has a impact on people, entities, and things on the internet. So we're huge fans of the way the internet works. We just want to make it better. We're internet optimists. We don't see a sort of a dark path. We see a very light path and trying to get fun back into the internet. My history, I've worked in telecoms. I was at British Telecom for over a decade, then jumped to Wall Street, where I did infrastructure and network security, and then came to Juniper Networks. That's where I met Alan in the Valley. Obviously, you probably can tell I'm a Brit, but I came to Silicon Valley back in 2007. And we started the At Company 3 years ago after a sort of classic Silicon Valley cup of coffee, where a colleague of mine was, well, we were both lamenting the way the state of the internet was. And Kevin being Kevin said, well, let's start writing code. And it sort of got out of control from there.
Very interesting value proposition. Looking forward to your talk.
Thanks.
Next then is Thomas Forster of Nokia, coming us from München, Deutschland. And almost all of us think of Nokia as a big telecom equipment manufacturer. But I was told that they have their own cloud computing and their own data centers. And Thomas is going to tell us about that during his talk. Please introduce yourself, Thomas, and Nokia's involvement in cybersecurity for data centers.
Yes. Hello, also from my side. My name is Thomas Förster. As Alan also mentioned, Nokia is a telecom equipment vendor, supplier for decades already. Our mission is to provide the equipment for critical infrastructure. Infrastructure means telecommunication primarily. And over the generations of telecommunications, 3G, 4G, 5G, also the technology has evolved and is more now running at the cloud, cloud native. And this is what Nokia cares about. Myself, I'm working in this industry, telecom industries, the last 25 years. I started at Siemens in exactly the same area. And with the joint venture with Nokia, I joined Nokia. And for the last, let's say, 10, 15 years, I'm in the cybersecurity business, especially. So in cloud native, core network and services, we have an own business line, security, taking care about cybersecurity, provide a portfolio to protect and secure the network itself by means to provide access, but also to monitor the network by telemetry data. And I'm the product manager of this team.
Thank you, Thomas. During your presentation, I'm going to kindly request you to talk a little bit about cloud native. It's one of the most popular buzzwords, but few understand it. In particular, the 5G standalone core network is supposed to be cloud native, but I'm not sure if it always is. There are very few deployed. So more about cloud native later. Now, the format of this session is as follows. Each of the speaker panelists will make a short presentation. They'll have view graphs, which will be uploaded to the ComSoc SCB website, hopefully next week. And then we will have a two-part Q&A session. The first will be questions from myself and Ahmed Amir, Professor Amir, the Master of Ceremonies for this event. And then we will take questions from the audience via chat. So as the panelists present, please think of questions you have and jot them down in the chat after you've given careful thought. And I will call those and consolidate them during the audience Q&A. So Jimmy, you're first up.
Hi.
Jimmy Jones of Zariat will now be presenting. Again, each speaker panelist has 20 minutes.
Okay. Can you see my screen okay?
Fine.
Brilliant. Okay, so I'm going to be covering a lot of technical topics, but I want to mention one thing before I start. Okay, very slow response. When you think about mobile networks, you think about a lot of things, basically because telecoms has been an integral part of our lives for the whole of our lives. But when you put it together, what you have is trust. And I can prove that to you. Because if you go home tonight and God forbid, your house is on fire, you're going to ring the emergency services. You're not going to message them. You're not going to WhatsApp them. You're going to pick up the mobile phone and you're going to ring. Because telecom is literally your lifeline, and it has been for all of our lives. And with connectivity about to exponentially increase over the next few years with IoT, there's an argument that reliance is actually going to keep growing. That trust is telecom's USP. And keeping it is essential to its continuing success. And the only way we can retain trust is by being secure. So as I highlight some of the security challenges over my 20 minutes, please keep that thought in mind. Okay, so we've all heard how telecoms is changing. It used to be a very closed environment with specialist equipment, vendors and protocols. And that does provide a level of security by obscurity, if you like. The less people know how it works, the less people can hack it. Even within telecoms itself, there used to be distinct silos. So I started in the 1990s. I worked as a switch engineer, building and maintaining exchanges. So I was in the core, but I never really got involved in the access network. Billing was just a query, if there was a query. And that rigid way of working, while it has eroded a little over the last few years, 5G is still a really big step, because more than ever before, 5G leverages well-known technologies to create efficiencies and drive innovation. And that's absolutely essential if we want to realize the network's potential. But what it does is it removes that obscurity. So now the well-known vulnerabilities from other environments can be reused. And that includes the cloud native stuff that Alan just mentioned. We're also dramatically increasing the complexity and diversifying and opening up the networks, all of which have a negative effect on security. Not all 5G's problems of its own making. Legacy networks have issues too, and that's going to play a significant part. In fact, 5G is actually the generation where security has been considered the most, and I think there's been some real progress. For instance, the 5G RAN, there's been a lot of focus on that, on confidentiality, data integrity, man-in-the-middle protection, and that's resulted in stronger ciphers. But finally, it's also allowed us to address IMSI catches or stingrays, which have affected every generation before. So an IMSI is the unique identifier used in all networks to communicate with every individual device. And an IMSI catcher is a fake base station that devices connect to, thinking it's the real network node. Once that happens, the perpetrator has created a denial of service, but potentially also is able to harvest data or even create a man-in-the-middle attack. In 5G, the IMSI is, well, first of all, it's renamed. It's the SUPI, Subscriber Permanent Identifier. But now we use the elliptical curve encryption functionality, which is present on all of the newer SIMs in 4G as well. And now during the registration to the network, the SIM never uses that permanent identifier. Instead, it uses an encrypted version. That's called a SUKI, or subscription concealed identifier. And this is done from the initial registration. So that permanent ID is never seen. Even after that, there's another layer where a temporary identifier, the GUTI, the global unique temporary ID, is used. And I really think that mutual authentication in that exchange is really very good. And it's really nice to see the SIM functionality actually being utilized, because it's been there for some time. What isn't going away, though, is the legacy cores. With almost all of today's 5G networks using LT or 4G cores, even when they do move completely to 5G or standalone 5G, to give its proper title, they have to support the legacy protocols to be able to allow the maximum global coverage when customers are roaming. So what that means is we'll continue to see issues like location tracking, SMS interception that appear in the media fairly regularly. I thought it might be interesting to walk through one of those legacy attacks just to show you how easy it can be. But I need to give you a quick bit of background first. Telecoms operators connect to each other via IP exchanges. So there's around about 1,000 operators globally, and they, instead of connecting to 1,000 different operators, they connect to a IPX, and then from that IPX they can connect out. So it works as a hub. The problem with that is if you can access the IPX, you can send a packet to any operator. So how do you get access to the IPX? Well, it could just be through a really poorly secured telco on a small island somewhere, or maybe you just bribe a disgruntled employee, or you can just skip all that and go to the dark web and buy it there. Once you have access, you can use the protocols that weren't really designed with security in mind. SS7 is the one that comes up the most. It's used by hackers the most. It comes from probably about 30 years ago, when it was still 4 wires run between 2 operators to connect them. But now it's been ported onto IP without any changes really for security. And that is still the network and still the protocol used to connect most network operators today. So you have access. And the first thing you have to do is get the network identifier, the IMSI I mentioned a little bit earlier. It's different from the telephone number, but there's a couple of ways you can do that. So if I take your business card, I've got your telephone number. And from that, with my access to the IPX, I can send a message. It's called send routing info for short message. That's the one that's normally used. And if I format that correctly, the network will respond with your IMSI, which is your network ID. And from that point, I'm in business, because on that point, I can create and I can look for your location. And we saw, when I used to work in my previous company, we used to see hundreds of these location attacks when we used to put a network node on. The way I do it is I send a message called the provide subscriber info message. And when this is received, the HLR will respond with the details of your cell ID. And that's broken down into 4 elements. Once the hacker has them, he can convert them to hexadecimal format. You can do that on the web. And then you can also use another web online tool, a cell finder, to be able to find the location of that cell. So the English one there is pretty easy, but it has less cells on. The bottom one's in Russian. That's really good, to be honest. You just have to remember where the 4 elements go or be able to read Russian. Should the provide subscriber info not work, there's lots of other messages you can try. If SS7 doesn't work, then you could use diameter. Process is pretty much identical. You use the IPX to deliver the message, and you do the lookup on the web again. When you use these methods, you're locating the device's cell tower. So the actual location can be with anything within that range. So if you want to be clever and you want to boost the accuracy, what you can do is you can send a silent SMS or a unstructured or a USSD message. Those messages will activate your phone, make them communicate with the network, but they won't show you anything. It won't light up, it won't bleep, it won't do anything. Now you have those, and if you've moved cell towers, you're now able to cross-reference and get a more accurate location, because you'll be somewhere in between those two. So you can triangulate even the location tracking. So it's not many messages. We're talking 2 or 3 messages. You can protect yourself. The GSMA has some great advice for operators. You can see the documents there. But unfortunately, a lot of the operators don't do it, some of the smaller ones, or if they do, they don't stay up to date with the latest bypass techniques. So this is my personal bugbear. When you see a presentation for 5G journey, it often shows 3 steps from where we are today on the left to the non-standard option, usually option 3 that you can see, and then on to 5G. But that's far too simplistic. As I said, the legacy networks and their equipment are going to be with us for years to come. So those generations are going to coexist for years. For most operators, it will be a gradual deployment with more and more 5G elements coexisting and then replacing the 4G ones, until the point when 5G is dominant and 4G is just there to serve the legacy stuff that's hanging around. This migration is complex and time consuming, with other operators having to deploy new network elements and services while supporting previous generations and ensuring it all works seamlessly and securely together. The way they do it is normally using control plane separation or cups, and that allows you to provide a strategy to move from 4G to 5G. And you can see the migration in the diagrams at the bottom. In the EPC, you can see the PGW and SGW. S-Gateway. They're responsible for user plane and control plane together at the beginning, but when they start to move forward to be able to work into the 5G, they split until you have a S-Gateway control plane and a P-Gateway control plane and a user plane and P-Gateway user plane. And that matches exactly in to the session management function and user plane function in 5G. So you're creating a dual node network. And this is great, and it allows you plenty of time to move gracefully to your final decision. But combining those network functions while making perfect sense for the evolution brings 5G really into contact with the legacy networks. In 5G, the UDM is responsible for the user plane and the AMF for the subscriber registration and stuff. But you can see by coexisting with the diameter, they're accessed by the LTE roaming networks as well. And that's important because if you look at penetration testers stats, and there's a few of them will publish them, you'll still see that networks are susceptible to diameter attacks. It's a similar story for GTP with the 5G session management function and the user plane function in GTP. And GTP vulnerabilities, if anything, are more prevalent than the diameter. And don't forget, that's in today's networks, which are less complex, and 5G hasn't really been deployed yet. So potentially the problem could get worse. So what happens when you get to 5G? The introduction of 5G will see big changes in the architecture with the service-based architecture, mirroring the virtualization in other IT.
I mean, just to interrupt you for a second.
Mm-hmm.
I think what Jimmy means is that real 5G has hardly been deployed yet, and real 5G is the standalone core network, which he's describing now, as opposed to probably 95% or more of 5G deployments are 5G non-standalone, which uses a LTE anchor for everything else other than the RAN.
Yeah, exactly. So option 3 is how it's normally so if you look on this, it's at the top in the middle. That's normally where most people live in a simplified world. So yeah, thank you, Alan.
Just wanted to clarify. Thank you. Go ahead.
No problem. Okay, so there's significant changes with virtualization. So what they've done is they've kept some point-to-points, which is this box at the bottom, but they've created the service-based architecture, which works on which uses a single bus to communicate, and it also utilizes common protocols, HTTP2, REST APIs, etc. And they're still at the bottom. There's still some point-to-point. We keep the GTPU, but we add a new protocol in their packet control function, a packet forward control protocol. So that GTP is still there. So this is one threat that was identified by a penetration tester. It uses the shared bus. It utilizes the HTTP2, but it also shows how complexity can play a part even beyond misconfiguration. The researchers took particular interest in the network repository function, the NRF, because it's responsible for registering all the new network functions, holds all the information for the profiles. And the researchers looked at 3 procedures: registering a new network function, obtaining a profile, and deleting a profile. In their testing, they found that there was no TLS or other authorization performed, so they could perform all the actions with the results you can see. And that's a massive red flag, because TLS is required in the 5G standards, and it would secure the transport layer and the network element authentication. However, in the real world, in this case, the real world trumped best practices. I asked the researcher why he thought it was never used, and he said it was probably because the network functions in a service-based architecture can create functions dynamically. So compared with other networks, it's much more dynamic, and you need to be able to keep the TLS keys. You need to create them dynamically, but you also need to manage them throughout their lifestyle, and that can be pretty complex. So what we were seeing, or what he was seeing, was the vendors are not currently offering those keys management solutions. Instead, they offer a single certificate that can be used in all the network functions because it's easier. That simplified approach is great for encryption, but you can't verify that the endpoint is legitimate. So unfortunately, in this case, the threat of a fake network function was not covered. If TLS was there,
TLS is an acronym for Transport Layer Security. Is that correct?
That's exactly right, Alan. Yeah.
Okay. So everyone knows, because I like to have all the acronyms spelled out for those who aren't sure of them.
No, I appreciate it. You get blasé with acronyms, and I know I do. But what TLS does, if it was employed, it would give you the privacy for the encryption, the integrity checking from the hash value, and the authentication via the certificates. So we need to make sure that best practices are adhered to. I spoke about the legacy roaming. 5G is trying to address it with two new elements: the Security Edge Protection Proxy, SEPP, and IPUPS, Inter PLM User Plane Security, I think. The SEP addresses the control plane, basically authorizes if the subscriber packets get from A to B and uses the N32 interface. You'll hear about a lot in 5G. IPUPS does the same, but for the data. The SEPP uses TLS to create secure connection between operators via the N32, point to point, operator to operator, though it can also be used in print. This gets a lot more complicated. It's basically the IPX providers add in additional info to keep their value up and avoid them becoming a dumb pipe. The IPX also offer a hosted SEP for operators as well, a sort of SEP as a service, I suppose. So what's the problem there? So the SEPP is a 5G firewall. It's the only point of contact in and out of your network for the HTTPS, which is the protocol used. And what I've just described is basically a transport layer connection, but all network operators use whitelist. All IPX providers use whitelist. So what's the reason for hosting the SEP? Because what I said earlier was the way that operators are being compromised over the IPX at the moment is a disgruntled employee or purchasing dark web access. None of those are actually resolved by the encryption. What you need is the SEPP, is the filtering rules. So actually what's the most important thing is the filtering rules. And those filtering rules are very similar to the signaling firewalls are doing today. And they get bypassed on occasions. So the SEP is better, but it's definitely no silver bullet. Open RAN, I'm running out of time. Open RAN is a hot topic at the moment. The NIS cooperation is part of the EU initiative. They released a really good report a week or so ago. What that does is it moves us from a single vendor RAN solution. One company supplies all the three boxes on the left. It opens up and standardizes interfaces, which means you can use any vendors in that complex diagram on the right. This does a few things. It opens up the market to niche players, allows you to innovate, removes the dependencies on single vendors, and also allows more competition, so lowers prices. The Open RAN also allows access to AI and ML for management, and all of that drives complexity, and complexity is the enemy of security. Complexity is just a start, though. The open interfaces, and by open interfaces, I mean proprietary, not that they're not secured, will use APIs and other protocols that are well known to attackers, so they can reuse that. And interconnect points are the weakest link of any network. Those interfaces are also open to interpretation, and the standards are new. If you think about SIP, that's been around 20 years, and we're still using SBCs to be able to normalize the traffic between our networks. You're creating a commercial environment which will give first mover advantage, so you need to be careful of that. You're going to be for speed, you're going to be reusing third-party software, and that reduces some of the secure by design, which is key to security. So you could end up with Frankenstein's network, which is bad. You also have the extra supply chain, and coupled with virtualization, which I'll let Thomas talk about, and multi-edge compute, which again is complicating on the edge. You're creating a fog rather than a cloud. But everything I've said there, you could apply that to everything I've said about 5G as well. And all that's happening is we have that sea change I mentioned. We're no longer got three use cases: ring your mother, text your wife, surf the web. there's thousands, if not millions. And if you bear in mind that this is, you're going to be interacting with an IoT device every 18 seconds by 2025, you can see the size of the problem. Telco has to behave as part of the ecosystem now, because you've got to secure end to end. You can't secure IoT unless you know its DNA, that from the device to the network and the application. That's key. The end to end is key, because if IoT is to realize its potential, it needs to be trusted and secure. Because just as narrowband and IoT and LTE overtakes LPWANs for the first time, we're back to where we started. Traditionally, telecoms has always been there and been trusted. It needs to step up and continue to secure our lives for IoT to be successful. Sorry, I overrun a bit there, Alan.
Thank you very much. Again, we're going to defer the questions to the Q&A session. Just for clarification, LPWAN is low power wide area networks, and there are cellular types like LTE-M and narrowband IoT, and then there are unlicensed spectrum like LoRaWAN and Sigfox. Is that correct, Jimmy?
Absolutely.
Okay. Next up is Colin Constable, telling us how we can flip control of the internet from the core to the access or to the edge.
Thank you, folks. Let's start with this slide. So I mentioned in the intro, I guess you can hear me okay, Alan?
Yes.
Yep.
Perfect. All right, good. So I mentioned that our mission is to flip security and flip the internet. It's a difficult task, and probably the biggest problem we have, and actually Jimmy touched on it a little bit, is just the sheer size of numbers. We have more and more people joining the internet. Obviously, most entities on the internet now, but there's more and more entities. I don't know if you've seen the recent readings on this, but companies are getting smaller, which means there's more and more entities that are joining the internet. And then we have this explosion of things on the internet. I can't stress enough how difficult this is to manage. And we only have the tools that are at our disposal are pretty basic. They haven't really changed too much. We have walls, firewalls. We have tunnels, VPNs. And all of that stuff relies on staticness of IP addresses, staticness of configs. And if you're in the telco world, this is just incredibly complicated. In fact, it's so complicated that things are getting out of control pretty quickly, and we need to change. That I think is our biggest problem. How do you scale things when they're static? Well, you can't. It causes complexity. And that complexity causes no end of security problems. And what you end up with is diagrams that are not as neat as Jimmy's. What you end up with diagrams like this. This is the FFA diagram. I showed it last time at the presentation. I can guarantee you this has not got better. It's got worse. This is just a network diagram on top of everything.
Is that real?
This is a real FAA diagram.
It's unbelievable. I've never seen such a dense diagram.
It's quite spectacular. And if you look at the top, this is the simplified network access diagram.
Simplified.
And this is how our Federal Aviation Authority runs. This is not unusual. I can tell you all the enterprises I've ever worked with have diagrams that are very similar. They all have like the neat diagrams, but then they have the real diagrams, and there's static addressing everywhere. It's very difficult to manage, but that's the reality. You know, it's an increasingly complex puzzle to solve. So how do we solve these problems? These things have been these things have been causing us problems for decades at this point. How do we solve these problems? I think we solved them in exactly the same way as we've solved all other network problems. As these people, entities, and things join the network, we need to have a new layer. we haven't got that new layer. What we're trying to do at the moment is shoehorn people, entities and things into existing layers, and it's not working. We need to have that OSI level 7 network addressing that's universal, so we can talk to people, entities and things and actually know, who they are, what they are, and what services they can offer, what data they can have. But how do you do that? At the moment, we have the layers we understand and know. We've got good old Ethernet addressing. Nobody's asked me for my Ethernet address for a long time, but that used to happen. We have IP addressing. Everyone's familiar, I would hope, on that world. And we have this sort of DNS sort of halfway house addressing, which has given rise to cloud computing, services on the internet. Everything's actually just behind a DNS address. And even as I put out here, APIs on a DNS address, but that means that they're centralized. You can't speak to widgets on the edge of a network behind a NAT through a regular URL. That's just not possible unless you start writing customized code, and then that customized code gets really messy really quickly. So we need a new way to address stuff. And it needs to be ridiculously simple so everybody can understand it. It needs to get adoption. So what would that look like? Well, in the way we're thinking about it is everything just gets a really simple string. I get @Colin. You can probably see on my Zoom that I'm @Colin. And the IEEE could be @IEEE, and my Raspberry Pi could be @my Raspberry Pi. And that's a unique identifier at layer 7. So applications, devices, things, pieces of information can all have this new identifier. So it's addressable directly on the internet. And I think that starts giving us a new layer where we can communicate, and the network at the IP layer can do IP level stuff. And the network at physical layers, the Ethernet layer, can do Ethernet level stuff, and we get back to this idea of having proper and distinct layers within a network, so you can do the right thing at the right layer. Jimmy talked about DNA. The D and the A are actually pretty good, easy to do, but the application is just a world of hurt because everything's static, everything's defined by an individual protocol, which means you've got to have static configurations of firewalls and VPNs and the rest of it. That needs to change. We need to have this new layer 7 way of talking to things and entities and people. So how on earth you do that, and how on earth you do that securely? I can tell you the first thing you've actually got to this time be brave and build security into whatever you're going to build. And the only way you can build security in from the outset is make sure that people, entities, and things actually own their own keys. And not only own them, but with new technology, you can now get devices to cut their own keys at the edge. And actually, weirdly, Alan, as you called together this call and you said, can you present? Jimmy and I have been working on doing exactly that. We didn't know that we were presenting together, but we have been talking to each other and actually getting keys cut on a SIM actually at the edge. So this, the key doesn't, the cryptographic key proving that this is this device on this @ sign really is that device, and nobody else has got the key, so you can trust it all the way down to the SIM card, so it never reaches main memory. It's all locked in the SIM card is critically important.
I'm going to ask you more about that during the Q&A, Colin.
Awesome. Yeah, no, that'll be great. So if you've got all these new identifiers, we call them @ signs, you need to have a directory. You need to have a directory that scales, so you know where all those devices and things are on the network, which gives rise to, you have to write a new protocol. So if you've got a new network layer, you have to write a new protocol. So what protocol? What is that protocol? How does it work? How can we write that and get agreement across networks to put that protocol together? But they're the three most important things. Everything has to be distributed as far as you can. Everything has to cut its own key. And then you actually know who owns the data, and people can sign it and encrypt it, and you can have encrypted messages going between people, entities, and things from edge to edge. So sounds easy, turns out to be pretty difficult, but that's what we have to do. So, how would this really work? I'm horribly practical. So, great idea on a whiteboard, but like, let's go do it. What would it actually look like? It actually doesn't have to be that complicated. You can have, we've got a classic case of Bob and Alice talking to each other. You have people and their devices cutting their own cryptographic keys, talking in a protocol to microservices on the internet that provide each person, entity, or thing a particular place on the internet. And the particular place on the internet doesn't need to be complicated. It's just a known place in the directory where it has an IP address and port. So we can actually multiplex on the port. So you can look in the directory and say, @Colin, where is it? And the directory will say it's on this IP address and this port, and you can speak to the microservice. And the microservice can then cryptographically authenticate you to say, if you're at Ahmed, then you need to prove it, and you can prove it because you cut your own cryptographic keys, and then we can converse. So what does that give rise to? Well, it gives rise to, well, you don't need passwords anymore. You've got cryptography doing all that hard work for you. You don't need VPNs and don't need firewalls, so you don't need anything static, because all these, you notice these arrows are talking out. Everything's an outbound, so everything traverses NAT nicely. You don't have to have open ports anymore. You don't have to administer anything more than layer 7, and everything's addressable, and all those keys are kept at the edge. So you can have device to application encryption. So you can have a device, a blood oxygen meter, talking to a microservice. Everything's encrypted to the edge, and that information could go to your doctor, go to your personal trainer. You get to decide which data goes anywhere. And that's one of the dreams I've had for maybe 2 decades now, to actually be able to apply network routing to application data. So I get to decide where you can send data, not somebody else. I don't have to upload it to a website and then trust that website to send the data to the right people and not to snoop over it. That's what happens at the moment, right? So you have all these really cool services, but they're monetizing you as you're using the service. I just don't think that's acceptable anymore. We have to have device to application encryption, and we have to be able to route the traffic. So all those things that we do at the network layers at 3 and 4 and 1 and 2, we need to be we need to be playing at layer 7. So great talking about it, I guess. This is sort of the example. So you've got Tinashe. She owns a device, a blood, heart, oxygen monitor, and she controls where that monitor sends the data. So maybe the doctor gets the heart rate, the glucose data, but maybe the same monitor Tinashe wants to send to a personal trainer. The personal trainer just gets oxygen and heart rate. So you're actually controlling which people in this network at layer 7 get to see which bits of data. And having other attributes like time to live on data, be able to revoke it, be able to pull it back, all those things that we can do in networks we just can't do consistently on at the application layer. This is the stuff we need to do. So we've been doing it. This isn't sort of pie in the sky. So let the demo gods be with me, Alan, and we'll see whether we can actually do a demonstration. So
go for it.
Can you see prompts? Hopefully you can see my screen. Is that?
Yeah, I see it.
Yeah, you got it. All right. So I've got a machine here. It's called Kali, and I'm gonna run this command. You'll see some cryptographic keys being killed up over here. This is called SSH no ports or no ports. We're saying from the IoT manager. So this is to do with IoT. IoT manager, we're saying we're from the IoT manager, and that's my @ sign there. And we want to talk to the IoT device here. So that's our @ sign. So that's the @ sign we want to talk to. And we want to talk to this particular IoT device. And I want it to call out, send a message to this IoT device and get it to call back to Kali. So this is my machine here, and set me up with a SSH connection. So we are now logged into that IoT device, and we can LS. It's all good. So yeah, doesn't sound particularly cool, but the fact is that IoT device, we didn't specify an IP address. There's no IP address here. And yet we logged into it. The IP address just gets us transport. That's what IP address is supposed to be doing, transport. But I've addressed it by it says the IP address changes, don't care, I'm still going to get to it. It could be anywhere in the world, I'm still going to get to it because that's down at layer 4, not layer 7 where I am. So I can log into this device. So what is this IP address? Let's have a look. We do IP minus A or IPA. If I could type it, IPA. So this is the IP address of that device. So you can see it's behind a NAT. I actually should be able to nmap this. So if anybody's not familiar with nmap, it's a port scanning tool. So we're scanning all 65,035 ports of this IP address. Sorry. Nmap minus P1 through 65,035, and I will get this IP address right. Control C, Control V, and we'll see how many ports are open on this IoT device. Hopefully you would have worked out how many ports are open. Remember, I'm actually SSH'd into this device, but there are no ports open. How the hell did that work? Well, what I've done is use this new level 7 protocol to safely send end-to-end encrypted. This is what the keys are happening over here, new SSH keys. So this device can call back to me. So it's always an outbound call from the IoT device. That means this IoT device actually has 0 attack surface. Plus, the keys, if the keys are kept safely in a SIM card, this is a pretty well locked down device. And guess what? It doesn't matter what the IP address is, I can still activate it, which means all that horrible staticness that we have to deal with in the network layer at the moment can go away. And if there's no door on this IoT device, then why do you need VPNs? Why do you need firewalls? Well, simply you don't. So that's one demonstration of what this layer 7 protocol could do, but it doesn't really show you exactly what people would do. So I have another demonstration. This is one I didn't write. Oh, by the way, the SSH no ports is available. It's open source. Please find bugs. Please extend it, accepting PRs. So let's show another use case. So I'm logged in on my machine here. This is me. I'm logged in as @Colin, and I'm also logged in on my phone. This really is an Android phone, and I'm logged in on that phone as @AI6BH. It's my call sign as a ham radio guy, and I want to send a file. So I'm going to send a file to this guy called Colin. And I can select that Colin, and I can say done. So I'm going to send a file to that Colin. So pick a nice photograph. This is a meetup I was at yesterday, and I'm just going to send that. All I need to know is what the @ is. I don't need to know anything else, just the @ And I'm going to send a file. I can be anywhere on the planet, doesn't really matter. And we send that file. And if you that's it, sort of done on that, it will actually pop up in a second that says this file is sent, and you see this little red dot up here. I normally would actually send a notification. I switched them off because we're doing this call, and you can see there is the file from AI6BH, and I can download it, and everything looks good there. And if I actually go on the phone, look at the transfer history, I can actually see that not only was it delivered to @Colin, but it was also downloaded. So I can actually see what it's downloaded. And this is all working at the layer 7. So the practical, this is just a demo. It's actually a useful one. It's being used in Ukraine at the moment to send files end-to-end encrypted. So it's been sent from my phone over the internet using all that good stuff. No, don't have to worry about that. And that can be anywhere on the planet. It's been encrypted with the receiver's keys. So only the receiver can actually open up these files.
Where is the receiver located in this demo?
Receivers. This machine here. This is running on my Mac, and this is a screen share of my phone. My phone is on. Obviously, it's on the cellular network. This is on Wi-Fi. You can see it's on Wi-Fi up here.
So is it actually going through the internet? The
Yeah,
layer 7
yeah,
protocol?
yeah, absolutely. The file gets encrypted on my phone.
All right, okay, thanks.
Yeah, it gets encrypted. I actually create a new AES 256 key, encrypt the file with that AES 256 key. I drop the encrypted file on a file server, and then using the layer 7 protocol, I notify Colin that there's a file for you, and I also notify, oh, here's the key. Because I've got an encrypted, end-to-end encrypted link, I can send the key directly to Colin, and Colin can pick up that file, decrypt that file. You can also send it to, if I look at it here, you can look at groups. So there's a bunch of groups set up, today's testers. I can send the same file to a group, but only send it once because I share the same key with everybody. So there's some examples. There's a whole bunch of other examples of what we're doing at Layer 7 on our website, which you'll see in a second. But what does this all mean? And the demo worked, which is good. Demos rarely work, right? But that all worked. So you can see this is sort of our dev site. If you want to dev at Layer 7, if you want to contribute to the work we're doing, everything is open source. But what's the effects of this new network layer? That's really the big question. This looks like a few tricks, but this is actually bringing network technology to the application. Up to now, we've been subservient to the applications, and it drives me crazy that network technology is not being brought to the application. We have to all sort of bow to the application. Don't have to do that anymore. We need to be working together with application developers with a protocol that they can use and understand. The net effects are pretty fun. Well, they're profound. Let's put it that way. This is the way the internet works at the moment. You have to update all these databases, whether it's your travel data, your work data, your banking data, your shopping data, every single day. One of my colleagues moved house. He's been keeping a tally. He's at over 430 people he's had to update just of his address. That's crazy. And yet we put up with it. This is because of that simple addressing problem we have. I'm not addressable. I am not addressable on the internet. But with the Layer 7 protocol, all of a sudden I am addressable. Those applications can actually ask me. They know I'm at Colin, and they can ask me. They have to prove who they are cryptographically, and if I trust them, then I can give them that data. So all I have to do is update my address once, and all that data just automatically flows out. And I think that's a game changer for the world. And I invite anybody who's interested to come join us because it's an open source project. And I think it's desperately important to bring network technologies to the application layer.
Was the previous slide how people can join?
Yeah, I'll put it back up, Alan.
Yeah, we'll post that.
Yeah, please do. Yeah.
If you want to copy it now. Okay. So thank you very much, Colin. Next up is Thomas. And I'm really interested in Nokia's work in data centers, and in particular, critical infrastructure. So I hope you can give us some more background and perspective on that before you launch into the anatomy of the cloud data center attack. Floor is yours, Thomas.
I need to unmute myself. Okay.
You're unmuted. We hear you.
Great. Thanks very much. Yeah, first of all, Colin, it was a really nice and interesting concept and demo. It was really impressed. And Jimmy already introduced us to the kind of complexity we are involving our telecommunication network. No? So he took us from the 3G throughout the 4G and now towards the 5G. And as you may recall, the number of network functions were actually increasing. And he also touched on the ORAN topic. This means on the RAN side, the past years, it turned out there are few vendors only to provide the equipment. With the ORAN initiative, we have new incumbents who enter the market and allow us throughout a decomposed RAN to provide new technology, but also new flexibility. But with this, it's actually also a downside, because since it becomes more complex, the attack surface is actually increasing, and the threat vectors. And as the RAN, for example, is not only running on a virtualized environment, like for example a virtualized RAN, also the majority of the ORAN vendors are utilizing a containerized environment. This means using IT-like equipment and servers, running then, for example, Kubernetes on top of this with a Docker environment, and the workload are then the microservices. And as microservices tend to communicate not only within the cluster, but also then external, the interfaces are exposed to the public. And typically the communication has to be encrypted. So TLS is mandatory there, but still there's, for example, also there's SSL protocol used. TLS is using always certificates for authentication. So we do not talk about user password stuff, rather than encryption utilizing the certificates. Certificates tend to expire. And in the past years, the certificates were issued for a couple of years, then might get compromised. Nowadays, with this kind of new technology, we introduce short-lived certificates. This means they need to be renewed every time. And this, I would say, already gives a glimpse on how complex it is in a network to operate. This is on the RAN side, but also on the core side. Is in 5G world, we introduced the slicing, being able rapidly to bring up a kind of new network slice for a dedicated purpose, for example, an IoT slice or a healthcare slice, or just a gaming slice, or for a certain event like the Super Bowl, just to allow or introduce new services just for this event around this weekend. And this requires that also on the core side, new network functions are being rapidly brought up. As throughout the previous generations, typically this was bare metal deployment or a virtualized environment deployment. This still could be handled somehow manually. But in a containerized environment, these deployments need to be orchestrated by a service orchestrator in an automated fashion, so that it can be tested upfront, configured upfront, so that it's brought up on the need basis. And this actually widens also the attack surface, the threat landscape, and it needs to be actually addressed. And let me just move forward. As we are monitoring, investigating, spending our efforts in also in security, cybersecurity, we see actually a few key trends I want to share with you here today. The first one is the changed attack profile. As throughout the last months, the last years, we could see that our service providers, our carriers, are more under attack. There are prominent examples in the public where service orchestrators in the US and in Europe are being successful attacked. And this means not only at an IT level, but within the network itself. What we can see that the attack techniques become more complicated. Multi-stage attacks are being used. And without spoken, the geopolitical situation becomes worse the past months, with also creating the fear, the uncertainty, and the doubts. On the 5G network security, what we can see is the majority of the vendors are still focusing on the IT stuff. So perimeter security, like firewalls, for example, routers, then also the privileged access so that the network operations is somehow being monitored. But we still lack in advanced telco security. And as the network becomes more distributed, more complex, there's actually a demand on 5G specific use cases using new technologies like machine learning, AI, and automation. And the detection should be based on multidimensional telemetry data. Slicing, the new kit, is supposed to bring the dynamics in the network. For what reason? To monetize the opportunities. So to not only to provide a new data type, but to make this more purpose-built, more attractive, to enable the B2B or B2B2C business. So operators look into opportunities like this. Also, while the network becomes more dynamic, service chaining with exposure of new services, for example, security services, would be possible. So the industry talk about that. But the network is still relying or is relying on a cloud data center. So all the majority of the components move towards to the cloud. It's for the core, but also for the RAN. And with this, also our security controls need to move towards this environment, to respect this environment, to understand this environment, to provide the right insights. Also, our security operation environments move, therefore, to the cloud. And cloud providers are, for example, our new hyperscalers. Yeah, so the Microsofts, the Amazons, the Googles, the IBMs. And the last trend is then that the network functions, they have valuable data, which are able to monetize. And monetize means then to provide interfaces via, for example, the NWDAF, and to provide the interfaces so that applications can attach to the network, utilize the data the network could provide to provide the right insights. Also, the eSIM and iSIM is going to mainstream. And so the classic SIM is almost gone. So the new phones are more utilizing the eSIM, and the iSIM is on the horizon. Automation, I would say, is a key. And not only the network automation itself, but also the security automation. As you may imagine, in the past, as everything was manually deployed, tested, also the security controls could be configured in that fashion. It it's always a month or years a rollout that a new kind of network portion is being distributed and configured. Nowadays, we think, and we can see also the security controls need to be automated, so that as soon as new network functions are brought up, new slices brought up, also the corresponding security controls need to be put in place as well. Coming to a kind of anatomy of an attack scenario. As we work with service providers together, and our security consultants are staying beside to help the service operators to with consultancy to propose what is the right design from a security point of view as well. Also, we investigate in real events of attacks. And typically, and here I take one example, it starts actually with kind of social engineering, that a group of attackers start looking for utilize the social media, like for example the business networks, to identify possible targets who are working for service providers, who are working, for example, in operations, with the aim to pass, for example, multi-factor authentication. As you could imagine, such critical networks are not only controlled via a firewall, and then someone is logging in with a user or password or so. So there are certain security controls in place in the operations which prevent that unauthorized personnel is able to access. And multi-factor authentication is one of the security controls. So the attackers know this and try to identify the persons, and then need to be aware, and two-factor authentication is in place. How to bypass two-factor authentication? So in the old times, the one-time code, for example, sent via a text message, we know that it's already broken. Someone may ask to identify a person, and then from the operations, and ask for a new SIM and redact the SIM card. And as soon as someone enters, then wants to access the systems, the one-time text message, or the text message with a one-time code is sent then to the attack. So it's about that a person, a network operations is a valuable target for an attacker. Phishing is one way to gain access, to steal the credentials from the operations. As soon as the attacker would be able to bypass the two-factor authentication, he may get access to the network itself. It might be to a lab, but the lab is then also connected to the production environment, or even directly. As network operations typically work with network monitoring or network management systems in the OSS field, these systems are typically monitored. But it, on the other hand, also possible to have direct access then from an operations center into the production environment, using, for example, the CLI. As soon as the attacker proceeded in that way, he may get an access to a network function. We know nowadays we talk about IT equipment, so we have always often an Linux operating system in front of us. he of course would need to have a telecom know-how, so how the network is working. But as soon as he has access to one node, he may then start trying to find out how to escalate with privileges, for example, gaining root access. He may then start discovering the topology. And in a 5G environment, Jimmy was introducing already the network repository function, which is a central repository of the 5G core. Gaining access to a network resource repository function allow me as an attacker to obtain the available services, the IP addresses, where they are. Typically, it's protected by TLS and certificates, and optional the access tokens. But here in my real case, the hacker was hunting for the HSS, so the home subscriber server where the subscriber data is located. It's running on a virtualized environment, so he would need to know about the virtualized environment there as well. And in this moment, he has actually several options how to proceed. He could, for example, take a kind of proof and send it to a CEO. Say, here I'm in your network, and ask for ransom. Or he even don't need to do that at all and just erase the network function. The harm is that the service, in this moment, the 4G network is taken down, as nobody else is able to register anymore. The network is not able to respond to new requests. So ransomware itself, or ransom, is not always asked.
It's not mandatory.
It's not mandatory, as is then more about the damage and the reputation. And having in mind the geopolitical situation, you may think of how it could go, or the ransomware. But I would say these kind of skills, what is necessary, requires technology skills, and not only from an IT perspective, but also from a telco perspective itself. So what are the takeaways? What to learn concerning data center security? First is to identify where are the security controls, what security controls need to be in place. And here I'm particularly not talking only about perimeter security, protecting the network by the firewalls, by the network operations, by privileged access management systems. So what are the security controls in a network? And in a 5G core, standalone core, for example, the certificates play quite important role. The NRF, so the network repository function, plays a quite important role. The service orchestrators, the infrastructure. And not only to identify, but to design the network, to have these kind of security in mind, to ensure that the security is there. But the standards are always allowing optional security controls, which are actually good to have in place. So having this security assurance right from the beginning in mind is of importance. The second is the protection. So privileged access to the network, allowing to monitor who is accessing the network. And here I mean not only to take all what is executed through an CLI, but also video recording, what the people do at the network. Then preventing or one security control to have a larger movement is to introduce individual credentials per network element. As network elements are typically monitored by the OSS, we talk about hundreds and thousands of network elements. The industry that tend to share the credentials among several network functions. As an attacker would know the credentials of one, he may be able to use the very same credentials on another as well, and that need to be prevented. And define fine granular role-based access. Who is permitted to access what by when is of importance. The third lesson is how to detect. So we have the perimeter security in place. We have the SIEM systems collecting the security events. We have probably the privileged access management, which is also monitoring the access. I think this is not enough in a containerized environment. So monitoring also the infrastructure and the network functions directly is of importance. Then running regular audits. And here I'm referring not only audits to vulnerability scans, for example, but also identifying misconfigurations or deviations from security standards, like, for example, the GSMA, NISAs, or the CIS benchmarks. The fourth learning is how to respond to an attack. As we know, the security controls, we reduce the risk being a successful attack, but we are not able 100% to prevent it. So we need a security in place which allow us to respond, to detect and to respond to emergencies, like, for example, being successful attack. So verified procedures, playbooks, which helps to react timely in such an event. And have these procedures already integrated into the enforcement points, being able to log out certain user groups, to verify the backups are taken, so that we are able to restore in a timely manner. And the fifth learning is how to recover from an attack, by means to take regular backups, online backups, isolated backups, separate them from the normal network, from the management plane, so to an own backup plane, and to plan for the business continuity, by means not only on paper, but with procedures, and test these in a regular fashion.
Thomas, just for clarification only, when you say backup, you really mean redundant systems, correct?
Yes, and backup, for example, my example was the HSS, so the subscriber database, to take a physical backup of the data and store it somewhere else.
Right. So that the database would be replicated on another storage element.
Correct.
Correct.
So that in in that event that the HSS is being erased, the restoration time is limited to a few hours and not 2 days.
Thank you.
Okay. With that, thanks very much.
Thank you very, very much, Thomas. Now, before I ask my questions, I'd like to encourage the audience members to put theirs in the chat. I see we have quite a few already, but I'll try to consolidate them after I conclude my questions, and Ahmad has an opportunity to ask his. I'm going to ask my questions in a random order. I want to ask Thomas first. Let me make a statement that the audience probably is not aware of. One would suspect that 5G security standards might come from the ITU, but it's not happening, that they're all coming from 3GPP and GSM. And in the 3GPP security specs, they state that all features must be implemented by the vendors. And these are the vendors who are providing security for a 5G standalone core network. But they're all optional for the network operators, which leaves one to wonder, is there going to be consistent security implemented in 5G networks throughout the world? So having said that, made that statement, Thomas, here's the issue. With cloud native 5G standalone core network, the security control moves to the cloud. And you have new software constructs like containers, Dockers, microservices, orchestration sessions, and automation. And this results in more exposed interfaces, which widens the attack surface. As a result, my question then is, would such a 5G standalone core network be more vulnerable to attack than either a 4G LTE network or a 5G non-standalone network, both of which use Evolved Packet Core or EPC rather than cloud native?
I would say yes and no.
And after you're done, I'd like Jimmy to weigh in with his opinion.
Okay, you are very right. So our security controls are defined by 3GPP and GSMA, and it depends on, for example, on one hand, on the vendor to provide the product security, and the hardening specification to close the system as much as possible. To regular also to ensure that the software is up to date. So as soon as we talk about container deployment, but also applies to a virtualized environment, quite a lot open source software is being used, which brings vulnerabilities. So this regularly need to be maintained. And this is done throughout and designed for security process. We as a vendor ensure that the software itself is maintained. While the workload is running in a private network, so in a private data center, a security control might be that physical security, but also then there are the firewalls around. But still, the Kubernetes, the infrastructure, plus the virtualized network, the microservices are protected as it's a private data center. As soon as we talk about public cloud environments, it requires that also in a public cloud, security, additional security controls are taken put in place. And this refers then how this deployment is being designed. We as a vendor help the service provider with that, and we have even solutions on that. Whether this is, and if the security controls are in place, I would say the core network is not more vulnerable than in a private cloud.
Okay. Can Jimmy, you offer your opinion here? As a 5G standalone core network more vulnerable than either a 4G network or a 5G non-standalone network using EPC?
I think I think the blur is already happening when you move to the evolved packet core, because then at that point you're already virtualizing. As soon as you start to virtualize, then you're creating the opportunity that you're already describing. So you don't have to actually go to 5G to have NFV or Kubernetes. Or
so even a virtualized EPC, virtualized 4G core would have these same issues.
Yes.
Yeah, exactly. Because you can take that all the way down. You can take that stack from where you are running the service, it could be an HSS or it could be a 5G network function. You're still on a virtualized platform. That virtualized platform.
I forgot South Korea has virtualized their 4G core network.
Yeah, but you see it all over the place though, because what you do see with 4G is as you move into the virtualization on the core, it gets even worse actually, because you move to the 4G in the core, but you can't actually afford to virtualize the user plane because there's a problem with usually latency, stuff like that. So what you end up with is a virtualized core for the signaling with the user plane still using the physical devices. So actually, as you move to the virtualization, you're actually stepping it into an even more complex situation where you've got some things on tin and something on the core. But everything, as soon as you start to virtualize, you start to move. It doesn't matter if you use NFV or if you move straight into cloud native, you're still putting yourself onto a position where there's areas that can be attacked, and they're all using APIs, and APIs are present all the way down from restarting the server in the virtual environment that could be running anything, doesn't necessarily have to be telecoms, all the way up. Those APIs are always there. So if you can start to pressure the SDN, if you can start to pressure the NFV or the cloud native, whichever way you've gone, you're able to create an attack from an extra layer. So I think Thomas is right. When you start to move to 5G, yeah, you're making yourself more vulnerable. But to be honest, you've already crossed that.
You've already done that once you start virtualizing the core.
Yeah, you're already halfway in. And what I would say is at least 5G is designed to be that way. 4G is being pulled that way. So what you find, and Thomas might disagree with this, but what you find is when devices are shipped from, they were on a piece of tin, and now you want to virtualize them, a lot of the time the applications are taken directly off of that server-based design and pushed onto a cloud-based design. And that's not the ideal way of doing it. You want to design it for the environment it's going to be delivered in. So I think actually when you start to look at virtualization, you start to look at the ability to orchestrate and to be able to spin up devices on the cloud natively, you're actually probably better off. That's a lick the finger and put it in the air. That probably better off than taking it and trying to pull it from something where it was used to be on a piece of tin and put it in a cloud environment. So I think probably as you move into the virtualization, you're more secure with 5G, but only because otherwise you're just dragging something that doesn't want to live there into virtualization.
Just one comment before I ask Colin a question, and that is that to me, the major new thing about 5G is the URLLC use case, ultra high reliability, ultra low latency, which supposedly opens up a whole new set of applications, and in particular, mission critical applications. And my comment, and just say yes or no if you agree, that mission critical applications not only need ultra high reliability, availability, but ultra high security. And I'm wondering if we're going to get that.
But you're creating a fog, because exactly what multi-access edge compute is what you're doing to push that compute to the edge, to be able to allow the low latency, splitting up the design and putting half the application, the non latency critical elements within the normal cloud, and then pushing other elements out. Yeah, there's a worry there. We worked with some companies in South Korea in my previous company, and there was that element where does the cloud end? Where does my network end? And it was a difficult conversation. But I think that's why we're starting to see things around private 5G, where people are trying to grab back control. I think that's why that's such a big buzz at the moment. But yeah, you're absolutely right. So for IoT to realize its potential, it has to be trusted. To be trusted, it has to be secure.
I'm going to ask you more about IoT later, but now Colin is front and center. Colin, you've proposed a very interesting paradigm shift for internet security control, moving key control to the edge and to the end users. You've defined a new network control layer and a new layer 7 protocol. The question is, how is the ad company recruiting partners to get the big internet service providers and the IETF to endorse all that you've proposed? That seems like a very, very, very big project, a very tall undertaking.
Yeah, when we started the company 3 years ago, we reached out to all the good and the great, and I think the best comment I got back was from Tim Berners-Lee, who said, this project is very ambitious, and like, if Berners-Lee says it's ambitious, I'm guessing it's ambitious. Don't care, it's needed. I think everybody on this,
it's more than ambitious, it's a whole redesign.
It's not a redesign, so it's new layer, and I think
well, it's a redesign of the security control aspect.
Correct. Yeah, absolutely is, because it's needed, right? If you speak to any one of the carriers out there, they're suffering from having to manage all this stuff, and if we can give a new layer that is friendly to the network teams, but also friendly to the application teams, then you actually don't need to persuade anybody, because it's just damn easier. And that's what we've strived to do. We've made sure that everything's open source. What you see in our GitHub repos is what's running in production. We take PRs. We're not trying to push this down anybody's throat, but if it makes it easier, then people adopt it. And what we see at the moment,
but eventually you're going to have to take this to the IETF.
Yeah, and I spoke.
You're going to need a whole bunch of co-authors.
Yeah, no, absolutely. And so I spoke to the great. I mean, you know, I came from Juniper, and many of my friends are sort of dotted around the industry. And the recommendation I got from pretty much everybody was, if you went to the IETF, your company would die before any paperwork got agreed. And the IETF route, although good in the past, it just can't keep up. That needs to change. So we've taken a NATO approach. So the NATO tow hitch was not designed by NATO, right? So it's a famous tow hitch. Everybody in NATO uses the same tow hitch. But although it's considered a NATO standard, it actually wasn't developed by NATO. It was adopted by NATO. So I think our approach is, let's get adoption, let's work together. I can guarantee you what we've written is not perfect. But what we need is, people on this call listening, getting interested, wanting to know more, contributing, saying that's terrible, you should do it this way, we will listen hard. And as an industry, we need to solve this. And we need to, the biggest firewall we need to break down. And when Dave Ward was at Cisco and at Juniper, he used to say this a lot. We need to break down the biggest firewall there is in the industry. And that biggest firewall is between the networks and the network teams, and everybody thinks the networks and the application team. Right, there's a firewall behind there. We don't speak the same language, and that's crazy. We've got so much to learn from each other, and the best way to do that is a protocol that's useful for both those parties. So that's how we go to adoption. Pretty much everyone we speak to says, "Yeah, that's a really good idea," and then we show them what we've done. They're like, "Oh, that's good. Can I play?" And like, "Hell yes, we'd love you to play." So that's what happened with Jimmy and myself. Jimmy and us, we got introduced through a business colleague, and It's been a joy because everything that Jimmy and his team with SIM and infrastructure security just marries nicely. And yeah, maybe Jimmy can tell that story, and that's a pretty good idea around how that.
Colin, if you email me that page, your contact information, I'll send it out to the IEEE Exploder mail list.
Yeah, that'd be great. Yeah, we're just trying to create useful tools like SSH no ports. It's a useful tool.
We have an audience member question for you, Colin. Yeah. The audience member says, interesting approach to private virtual network, but what about allowing some restricted access to some other person, my doctor for an exam, for example?
Yeah, no, absolutely. So, I mean, that's exactly the way the protocol works. Essentially, you own your own data. You decide who can see it. What's unique about the underlying protocol is that every party on the network has to cryptographically prove who they are before any data flows. So my sort of classic example is if one of my colleagues, so @Kevin, looks up location @Colin, that's a regular address in the protocol. Because I know it's @Kevin, I can give Kevin an answer, right? But if my wife @Sarah asks location @Colin, I actually know who she is, and I can give her a different answer. So it acts very much like people, right? The people can ask you a different question, and you can get a different answer, and you can route different information to different people, and you can say you can only have this information for so long, or you can change your mind and pull back the information. So we have a chat app that we didn't actually write, a developer wrote, it's in the store, it's called Space Chat. And you chat with people and you can have your conversation here, and whoever you're talking with can have that conversation, they're interleaves. And then if they decide to take away that they don't like you anymore, they can actually pull away all the data they've had. You get left with your information, which is your text, but all those other ones have gone away. So this isn't happening at the network layer. This is happening at the application layer. So you can actually do that sort of stuff that we could only dream of. We're guessing at the moment on what, guessing what the application is doing. If you have those techniques actually at the data layer, then you can pull back individual messages. You can give all sorts of attributes and give different answers to different things.
All right, thank you, Colin. I'd like to go back to Jimmy and IoT. IEEE ComSoc SCB had a workshop on IoT and machine-to-machine communications in 2010. That was 12 years ago when I was still chair. I was chair 5 times of IEEE ComSoc SCV. And here we are 12 years later, and IoT has not lived up to its expectations in terms of being a big market. In fact, recently we had Sigfox filing for bankruptcy. They were the leading LP-WAN company from the IoT company from the get-go. You say IoT requires end-to-end security. We've heard that for the last 12 years. Why hasn't that happened yet? Why has the industry taken so long to produce solid security specifications that could be implemented and ensure trust?
I think 12 years ago we were talking about M2M. I think it
was called M2M, but TIA had a project called IoT at that time, and that's what they presented.
Yeah, but and you're right. But I think I think when you look at M2M and machine to machine, what you were really looking at were devices reporting back to siloed infrastructure, giving them the temperature of something or the price of something. It was information which together, it probably wasn't that important. Does it really matter how much, if somebody hacks your electricity meter and all it's telling you is how much electricity you've used in the last month, then is that information really that valuable, and is security seen as a risk? Well, that is that. And by the way, when it's not been successful, there's a lot of those dumb machines in the ground at the moment. But you're right, it's not been as successful as it should. But I think what we're seeing now, we're seeing a change. We're seeing a change in the way that IoT is used. Now we're not seeing dumb information being as much. We're not seeing information just being dumped in a big lake and then forgotten about. We're seeing it being analyzed with machine learning and with AI. But more importantly, what we're seeing is that information being driven back into devices to make decisions and actually do something. So the way I look at it is we've had enough trouble trying to secure IoT when it wasn't really doing much. So I put it down like a child. When you first have a baby, it's in the cot. It's hard to look after, but it doesn't do much. Where IoT is today is it's now a toddler, and it's going to start running around the room, putting its finger in the electricity socket, because
like
now
a 12-year-old toddler. Right now,
as a 12-year-old toddler, yeah, exactly. But if you look back, the impact we're looking at now, the speed of adoption that we've seen because of COVID, the speed of adoption we're starting to see now, the way that the access speeds are increasing to allow actually more complex solutions to be employed. I think that's where we're at. It doesn't necessarily mean where we're at now, how long it's took to get where we are now doesn't actually show how much we will move forward in the next few years. It's not that long ago that social media started. So really, you're only talking 15 years. If we start to see the acceleration we've seen with that, the impact that's had, maybe even if you look at just mental health, we see all that stuff around social media affecting mental health. Well, imagine what happens when you're using IoT and you're interacting with it every 18 seconds, which is what they'll say in 2025. You cannot turn your house off. You cannot turn your street off as you walk down it, and your office. How's that going to affect mental health? So if we don't start securing it now, and we have took a long time to do it, but I think telco is the most secure way to connect IoT devices. It has to happen now. It is happening now. And unless people are driving it, then it's going to be as socially unacceptable to sell unsecured IoT as it would be to sell a car without seatbelts.
Of course.
But if you think about it, in the UK, seatbelts were mandatory in cars in 1970 something. You didn't actually have to wear them till 1982 because the government didn't make you. We are seeing that happening. There's legislation going through in the UK. There's legislation already ratified in the EU, America, Singapore, Australia, New Zealand. They've all got these coming through. There is a stick and a carrot for IoT security. It will happen.
Okay, thank you very much. Ahmed, do you have any questions?
So I have two questions for Colin and a single question for Jimmy and Thomas together. Okay, so the question, I'll start with the first question for Colin. It's about @Colin. I'm thinking about the future and your children, and @Colin 2.0, for example, and @Colin 2.1.7.8. Okay, you see where I'm heading with this?
Yep.
Localized context for identifiers. How do you feel that, is there hierarchy, is there naming? How do you see that evolving as the namespace gets complex and ages?
Yep. So every @sign is unique. So there is only one @Colin. It's a unique identifier. I own it, and I own all the data behind it. And I can change the data behind it to whatever I want it to be. And it could be anything. So it's dynamic. It's not logged in. There's no, you can delete stuff. It is mutable. There is no blockchain in this platform because it's a network protocol. So there's no need for a blockchain. So everyone asks me, this sort of looks like a blockchain, is it? I'm like, no, it isn't. We actually tried that 8 years ago and it doesn't work. I've got nothing against blockchain, but for mutable data, it's not going to be a blockchain. So, I want to be able to delete stuff. I want to be able to change stuff. I want to be able to pass on @Colin to my family. All that stuff you have to be able to do. But what's really interesting is we really try to model everything off of humans and how humans operate. And humans are very, very complex, and they tell different things to different people. You have to be polymorphic. Humans are they don't even think about being polymorphic, but they are polymorphic. The same questions lead to different results in different situations. So, if I'm in San Francisco, somebody says, do you want a coffee? Yeah, I'm going to have a coffee, but it's going to have a hot coffee. If I'm in Arizona, do you want a coffee means, yeah, I want to have a coffee, but I want to have a cold coffee. All those nuances could be put into the answer because my ad sign's aware of all my data, my whole corpus of data, and yet nobody else can look at it. So if you imagine all that power of machine learning and all the rest of it, and I can look at it myself and nobody else can look at it, there's so many possibilities to that. And we have to build a system that can deal with all those unknowns. I mean, we have no idea how people are going to use this protocol.
Yes, but Colin, once you are the only @Colin,
yes,
the question then becomes, what do I call your great-great-grandchildren?
Yeah, they can have another @ sign, or I can pass down the @ sign. So it's a unique @ sign.
Like a sub address.
Yes, because I'm wondering about how this ages, because
Sure.
if I could consider myself @Ahmed Amer, but unfortunately, I'm not the only Ahmed Amer.
Yeah, no, the next one, whoever buys or selects the next one won't be able to have @Colin. So yeah, there's nobody on the planet will be able to have @Colin, just in the same way as nobody on the planet really should have my same Ethernet address. It has to be uniquely identifiable, and there's no reason you can have an @ sign that is exactly your Ethernet address if you want. It doesn't care. The namespace is huge. The namespace is Unicode, although we've only opened up for registration the Latin character set and emojis. So yeah, maybe my son wants to be, @Colin guitar, or my favorite @ sign of all time. I don't know who it is, but there's an @ sign that's been registered, which is a guitar emoji and then Dave, whoever that is, don't know. That's how we deal with the namespace, and there are there is a fee if you buy an @ sign. Then just like DNS, you want to keep the DNS namespace clean. There's a fee to keep that up to date, and if that doesn't get up to date, then it gets fed back into the pool, so that cleans that stuff up pretty effectively. But if you want a free @ sign, we want to make sure that everyone on the planet and everything can have an @ sign. Then you can get a free @ sign, but it's auto-generated. Actually, some of the auto-generated ones are actually a lot of fun. So that's how everybody can play. And if you've got a bunch of IoT devices, then you can make up whatever naming scheme you'd like.
Thank you, Colin. And so
did that answer the question? I don't want to avoid.
No, it did. It's especially when you mentioned the auto generation and the pay to continue recognizable or self.
Yeah, we looked at the Twitter namespace. It's a very similar namespace. Obviously, they've got @ and then a Twitter ID. They already have billions of Twitter identities, and there was a lot of thought that wow, they might run out. And then you add Unicode to that, and then you add emojis to that. You're not going to run out. Yeah, there are billions upon billions, if not trillions of. I haven't done that. I haven't done the exponent. There's an awful lot of combinations.
Thank you, Colin. And the combo question I have for Jimmy, Thomas, and actually also for you, Colin, has to do with turtles all the way down, right? So Colin, you're introducing a solution that's a layer atop of what we have.
Yeah.
I remember about 7 years ago coming across some beautiful work by DJ Capellas about an updated session layer. An updated session layer to smooth things, to make things both more secure and better. So it's this, you're trusting the layers beneath you. You're trusting the layers beneath you. You're going down to the hardware below. So the reason this is a question for all three of you is, how much does that affect what you're assuming? Because Thomas, for example, raised the issue of automated security deployment as service in the cloud as a business opportunity, even for hyperscalers. But as a hyperscaler, is there not value to me having control over my entire stack down to the silicon? So the concept of the stacking and turtles all the way down, are we making it worse? Do we still have to worry about it? Are we going to have to be resigned to the fact that maybe we can't trust some levels? How does each of you feel about that? Thank you.
Do you want to start at the top of the stack or the bottom?
Yeah, let's start from the bottom. Yeah, okay.
Hey, let's do that.
Actually, it's a good question, because at the end, Colin helped us to build the trust. Because actually you need to trust at the moment the network. But you have always the chance on the layer 7 to introduce an application layer security. So from the button up is how to trust a hyperscaler as we run then, for example, a core network on top of this. So how to ensure the network is operated in a secure manner. And this is about, for example, private endpoints, how the network functions are being deployed. And how they are shielded, and then it's about to monitor the environment. But all this, the users do not actually see. It's not exposed to the outer world, so that the carrier need to take care, and the service providers plus the vendors who provides the equipment, they need to adhere to this. And so the security from the network itself need to be ensured. The problem is that the devices, IoT devices, for example, attaching to the network, are they able to trust their user plane? So how the operator is then ensuring that the connection is somehow protected, for example, with IPsec. So this need to put in place, and this is what I was referring for the slices. There might be opportunities to provide security services that an slice is especially protected and monitored, and then with an API exposure, the user of the slice would be able even to get the insights towards the slice. So what are the security events for that particular slice, just to build the trust.
Any other comments?
I think it's a combination of everything. That there's a lot going on at the moment, and zero trust environments are stuff that bandied around. Yeah, I think that's one method you need to use, but everything is going to turn into an ecosystem. We can't stop it. There's too many moving parts now, and to create the solutions that we're looking at, it means you're going to have to bring in lots of different people, and they're going to need to collaborate. They're going to need to cooperate to actually be able to deliver them, and they're going to have to do exactly the same to secure them. And that works back with all of those multiple supply chains, all of those multiple options. So you need to have that collaboration there, but then to protect yourself, you're still going to have to employ a zero trust environment. But looking at the stuff that Colin's doing, particularly if you can take it, the higher you can take it up the stack, the closer you can get it to your user or your solution, the better you are, because if you can encrypt from there, then at least you know that as you overlay all of those different options, one of them may get hacked, and maybe you lose a network, but hopefully you've built it in a redundant way, and you can jump on a different IPX provider or whatever's gone down. So there's different ways of doing it, but I think there's no right or wrong answer. You need the collaboration to actually deliver it, but for security, you need to protect yourself. And somebody said to me once that the only secure network is the one that's switched off. So we can't switch it off. That's not the option. So we've got to go forward. So we've got to there is always going to be some element of risk.
Thanks.
I'll
Two more. You want to add something quick? Because I have two more
Yeah,
questions I want to squeeze in.
Go for it.
Okay. And I'm deferring my questions to the two we have from the audience. The first, most people have cell phones and use them almost everywhere, every day. To my knowledge, cell phones like the iPhone can be used for tapping, and locating devices, including other cell phones. The privacy information could be used as a tool to control people. That's a threat. Is there any solution or comments about this issue?
So
using a cell phone to tap and locate devices and potentially invade your privacy.
Yeah, actually, I thought. Sorry, Colin.
No, go ahead.
To give you the spoiler, I thought that the solution from the ad company actually helps on that. I think that the question is referring to, for example, the iText, that someone put somewhere and tag, and then other people may able to locate this. And this is about data and data privacy. And I thought the solution from that company helps to keep control of the data itself.
So it's really about data for sure, but also the keys. So if you're encrypting the data at source, then really the data is just a blob of stuff, and what you've got to really look after is the keys. And if you can get the keys in a place where nobody else can get to hold of the keys, then you're in a really good place. So we use secure enclave on a phone to keep the cryptographic keys, and when you need the keys, they get opened up and you use them to encrypt stuff, and then they get put back in the secure enclave. And to get access to your microserver, what will be even better, and this is what we've been doing with Jimmy and Keegan recently, is cutting keys on the SIM card itself and a public-private key pair actually in the SIM card itself, and then asking the SIM card to sign your authentication challenge. And then that challenge never gets into any clear memory on the device. It's only sort of private inside the SIM card. You can do the same thing on a TPM, but those things need to be really easy to do. They sound really easy to do, but there's actually some really complex technology going on there. And application developers that are not going to spend the time to do that. But if that just happens automatically, I think that's how you get adoption, and that's how you get applications using that technology without actually having to code it all each time. So the idea here is make sure it's ridiculously easy just to have that functionality without having to code it. And that's where we have to sort of bridge those gaps between the network and the application space. But unless it's easy, I mean, just like pull it in a library and it just happens easy. Then I think you're constantly going to be finding that battle island, and everybody's going to be doing it their own way. And then you can, if there's a gap in, one of those ways, then somebody's going to find it. And that's why we constantly have these sort of breaches, because we're not all working together. We're all working on our own little problem in our own little space. And I think the network world is probably one of the best examples of where everybody in the networking world has worked together to get IP working across the whole planet. It's just one of humanity's huge success stories. That's not quite the same in the application space. So we've got a lot to bring.
I think you need education as well, because technology is not always going to fix everything. So when AirTag first come out, they found that an AirTag communicates via a iPhone that walks past, because it's not connected to the network. It uses uses close. No, it doesn't use Wi-Fi, does it? Use USB. Not USB, help me out. But all you have to do, they found that if you put it outside someone's house who had an iPhone, you'd know when he left, because as soon as you lost contact to your AirTag, the guy's left home, and you can go in and rob his house. So it's not actually anything that technology does a certain level, but then ingenuity and educating people, and people understanding that actually my iPhone should be switched off to actually automatically send, which I think Apple do now. You have to enable it to allow the AirTags to bounce off of it. But Bluetooth, that was what I was looking for.
Bluetooth,
yeah.
Low power Bluetooth.
Yeah, I would have lost the power of speech. But so you need to educate as well. It's not all about technology. It's about people, and that's even with IoT. People are always going to be the biggest problem.
All right, let me have the let me ask the last question, which is 3 questions. I'm going to answer the first part of it. Recently, Broadcom announced plans to acquire VMware. That's would result in a very big company that has security software, cloud servers, hardware, etc. Is it a monopoly? Well, that question is out of scope for this panel. That is an antitrust question that will be settled by the Department of Justice. The audience member then asks, information is easier to access for a high-tech company because of having cloud data servers, big data. Could these resources be abused by high-tech companies themselves?
So let me jump in there and say that the architecture we're proposing, everything's encrypted end to end. So anybody in the middle can route data, but what they're routing is provably true that they actually can't understand or see the data. It's all encrypted. So you can act as a data center full of encrypted data, but the keys are all on the edge. And that means you don't have surveillance. It's impossible to surveil. So if somebody's using our system and you're using our microservices, we cannot see the data. We can prove to you that we cannot see the data. If you want to run it yourself, then you can prove to yourself that you can't see the data. That's not to say that data centers are not useful. They're incredibly useful. In the file transfer program I showed you, that file went to a data center. It was stored at a data center, but it was stored with keys the data center owner has not got. We need to get to those sort of solutions so we're not being surveilled, and we need to have new business models that don't rely on surveillance.
Let me try to rephrase the question, and maybe a little bit of a stretch, but is a cloud resident data center more vulnerable to attack than a premises data center like we have here at the Santa Clara University?
I would say it's the opposite. I would say cloud data center is far less vulnerable than your own data center, unless you're putting in the sort of resources that the big players put in.
Thomas?
Yes, I would agree totally to Colin. Even that you may think that it's a public cloud environment, it's actually more secure than the own one on-prem, because those hyperscalers put the security in place and professional, get it audited, etc. That it's actually more secure than the own one, because they spend the experience, the knowledge, the money they invest in this. And they do not do this only for a little data center or for one data center. They run these data centers over the globe.
Okay.
Yeah, I think there's 2 ways you look at that, though. So yeah, the data center is more secure from hacking, but the information, if you're just talking about the information, the Irish Council of Civil Liberties did a report the other day that Google's real-time bidding has provided marketeers with 178 trillion data points in the last year. And that's only the US and Europe. So you can multiply that for the rest of the planet. And those data points include what you've looked at on the web and where you are. So if you think that is an intrusion, then yeah, you've got a good point. If you're looking to secure your network, because even banks use the big clouds because they think they're more secure. And if a bank can't afford to build a data center more secure than AWS, then who can?
Yeah, so use the hyperscalers for IT security, but make sure you've got your own keys for the data so they can't be surveilled. That's a way to.
I've observed all the hyperscalers have ultra secure cloud resident data centers. They've invested a tremendous amount of money for that. Let me ask each of the speaker panelists if they have any closing comments or last words or their feelings about this session.
For me, it was a great session, Alan. I'm really happy that you invited me, and I'm 2 great panelists with me.
Thank you, Jimmy. Thank you very much, Jimmy. Colin?
Yeah, Always enjoyed talking to you, Alan, and thank you for pulling it all together and being a great compare. And to my two co-panelists, thank you. The only thing I ask the audience is, if you think we're on the right track, then please help us pull together the right solution for the industry and get involved.
I certainly endorse that. Very, very provocative proposal. Thomas, your last comment, last words?
Yep. Thanks very much being here. It was a pleasure. And actually, I took the idea from Colin with me. So because data is the new oil, and being able to control their own data is of importance. And the idea Colin was sharing here today with us allow us to do so. Thanks very much.
I want to thank all of the speaker panelists, Professor Amer, who set this up and acted as the master of ceremonies, and all audience members for your participation. Thank you very much. Until next time, all the best.